Hi, you want to learn how to run a real-time analytics solution in Fabric? In this video, under just 1 hour, we will be learning key concepts of real-time intelligence in Fabric, all the key components. What is Kusto? What are the differences between Kusto and SQL? And then we will be building a real-time analytic project using London Bike's real-time sample data set. We'll be ingesting using Eventstream, saving this data in KQL Database, bronze layer, and then we will be using update policy and function to move this data to silver layer, and then we will build a materialized view on top of our silver layer Eventhouse table, and then we will visualize this aggregated data in our real-time dashboard. We will also get visuals from our bronze layer, and then we will set up an alert on top of our event stream and our real-time dashboard. And we will also be building a derived stream on top of our event stream. Hi everyone, welcome to the channel. This is Reena. This video will continue with the Fabric series, and I'm really excited to talk about real-time data analytics in Fabric. If you are just starting with Microsoft Fabric, please check out my previous videos where I've covered how you can get started with the Fabric using free trial account. Microsoft Fabric key concept, an end-to-end data project using Medallion Architecture. If you really find this video helpful, please like and subscribe it. It really helps me keep going. So now let's get started. In this visual diagram, you can see data platform design for an organization end-to-end project. This is a Lambda architecture which separates it into two different layers. One is code path, which deals with the batch analytics involving high volume data which is processed periodically for historical analysis. It could involve structured, semi-structured, non-structured data which is ingested using data factory or data flow, and then it goes through different layers, bronze, silver, and gold under Medallion architecture. And data between the different layers can be processed using notebook or data flow, which is basically a low-code or no-code solution in Fabric. And then it all sits over one lake, and it's also integrated with Purview for storage and governance capabilities. And top layer is hot path, which is for real-time analytics for low latency, high throughput, real-time streaming data, which could be coming from your IoT devices, sensors, gadgets, and it will be processed ingested using Evenstream, transform. You can do transformations, or you want to store this data and further aggregate or analyze. You make use of Eventhouse, which is basically a collection of KQL databases, and then you can visualize or act on this data using activators or real-time dashboard. So we're going to talk about the top layer in this video. First, let's understand the different components of real-time intelligence in analytics process. First component is data source connections, which the real-time data could be coming from your Apache Kafka, Amazon Kinesis data stream, or Google Cloud Pub, Confluent, or it could be coming from Microsoft IoT or Event Hub, Azure Cosmos DB CDC, change data capture feature. And now next components involved is like, what do we want to do with this data? We want to ingest and process this data. That's where Evenstream comes in picture. Evenstream, and then we want to probably analyze and aggregate this data. So that can be done in Eventhouse, which is collection of KQL databases and KQL query sets. And after this, we want to visualize and act on this data, where we can make use of Power BI dashboards, real-time dashboard, Activator, and all these different features in Microsoft Fabric are available under Real-Time Hub, which is a single tenant-wide logical place for all your data in motion. We should also understand is all the different features of a real-time data stream and how is this different from a batch data. So a real-time data stream will have data which is unbounded, which is will keep coming perpetually and never ending, and it will also have data records which will be temporal, time-based, indicating when a particular event was recorded or occurred. We will be doing aggregations over temporal windows. For example, if we are calculating a metric which is showing is rainfall per hour, or we are showing orders which are placed in the last hour, or clicks in the last 1 hour or 15-minute temporal window basically. And it will be supporting a real-time solution. Now this is just a general design or an architecture for a real-time data solution in Fabric. You will have data coming from different sources, which could be internal, external, and then you will be ingesting and processing this data using Evenstream, which is a low-code, no-code solution in Fabric. And then we might want to maybe directly put an alert, take an action on this data. So we can do that, or we want to maybe visualize this data. Another route we could take is probably we want to do some aggregation on this data. Maybe we want to enrich this data, like it's not business ready. So for that, we can store this data in Eventhouse, which is a collection of KQL data set. And we can run a KQL query using KQL query set in Eventhouse. And then from the Eventhouse, this data can be visualized using a real-time dashboard, Power BI, and we can take an action using Activator. All these different features are in real-time hub, but it doesn't by default stores this data in one lake. It provides feature where you can configure to store this data in one lake, but it is not by default stored in one lake. Now let's look at do they store the data in one lake or not. So Evenstream that doesn't store the data in one lake by default. Its basically purpose is to ingest the data real time. We have Lakehouse. Lakehouse, yes, it does store the data default in one lake. It's for your batch analytic storage solution. Then we have KQL databases. It doesn't by default store the data in one lake. It's used for streaming queries over real-time data. And you have data activator. That also doesn't store the data. It is for triggering the real-time alerts or actions. Now you must be wondering why not one lake? Why doesn't it store the data in one lake? One lake is optimized for your analytical workloads, like data lakes, where data is stored in form of Delta Parquet format. Your regular warehouses, structured data is stored in tables. And then you have Power BI semantic models, whereas KQL database is optimized for your streaming workloads and high ingestion telemetry data. And these storage systems, they are purpose built and they're separated by design in Fabric for performance and cost efficiency. While working with real-time data solution in Fabric, you will be hearing a lot about Kusto. So you must be wondering what is Kusto. Kusto is a high performance columnar database design. It's built by Microsoft, and it is used for real-time analytics, especially for scenarios where you are dealing with application logs or the IoT sensor data, website clickstream, security event monitoring, and the different components which are covered under this are Kusto Query Language, which is a SQL-like language, but it's interact with Kusto data. And then you have Kusto Engine, which is a backend engine designed for fast ingestion, compression, and parallel querying for large real-time data sets. You have Azure Data Explorer, which is a Microsoft managed service which exposes the Kusto clusters to Azure users. And then now we have KQL databases in Microsoft Fabric, where Microsoft have implemented Kusto in Fabric. And now also let's quickly look at key differences between KQL and SQL. Kusto will make use of pipe operator, and KQL is best used for logs, telemetry, time series data, whereas T-SQL is used for relational data, transactions data. KQL is optimized for read-heavy workloads, whereas T-SQL is optimized for transactional operations. Now you can also implement Medallion Architecture on your real-time data in Fabric, where data could be coming from your different sources, and then it is ingested using Evenstream and stored in Eventhouse KQL tables, where the data then can be ingested in Silver Layer and remove any duplicates or enrich this data. And you can make use of update policy using functions, so you do not have to manually run this query or orchestrate this so that the data is refreshed as you have incoming data in your bronze layer. And then in Silver Layer, you can make use of materialized view, which is a better way of running your aggregations instead of running on a raw table. And it doesn't need to use update policy. They have by default inbuilt, so you do not have to worry about refreshing this. As you have more data coming in, it will be automatically reflect the new data. And then in gold layer you can do further aggregations or apply any business logic and make it business ready. And then this data can be further visualized and act upon using Power BI dashboard or real-time dashboard or data activator. If you want, you can make available of this data in OneLake. You can do that. You can configure the settings. We will be building end-to-end real-time project. We will be utilizing London bikes real-time sample dataset, and the goal is to build a real-time dashboard and send a personalized alerts for the bikes availability. Bikes sample data, which is available in Fabric, will be ingested using Fabric Evenstream. This data will be then stored in Eventhouse KQL Database or data. Then we will make use of a function and use an update policy so that this data is then stored in Silver Layer, which is a KQL database. This is enriched data. We will build a materialized view on top of that for the gold layer. I will do some aggregations, and then this data will be visualized in real-time dashboard. You can also visualize the data from the bronze layer also. And then we will be using this real-time dashboard to send an alert using Activator. We will also be setting up an alert on the Evenstream itself. So now let's go head to the Fabric. Now we are in the Fabric UI. First, let's take a quick tour of Real-Time Hub. So this is where you can see all the different streams or Eventhouse or tables, and here you can see the different data sources. You have connections, Fabric events, if you have subscribed, if you want to subscribe or subscribed, or any Azure event. This is your real-time hub. Now you can get started from here. You can create a event stream. Or first, let's go ahead and create a new workspace for our project. We're gonna call it Bikes RT Analytics. Okay, now in this workspace, first let's create is Eventhouse. Okay, let's give our Eventhouse a name. It's called Bikes Eventhouse. So now this is a KQL database workspace. First, when you create your Eventhouse, it will create a KQL database with the same name. And then you can create more KQL databases if required. This is overall Eventhouse overview it's providing. Right now we don't have any data here, only one database. So now this is just overall system overview. This is all the different databases you have available. If you have multiple databases, you will be able to see them here. This is Bikes Eventhouse. Okay, and now let's go ahead and click on it. When you go to the event KQL database, you can create a table or a function. You can also create update policy or materialized view. Right now we don't have any options, so that's why these are all grayed out right now. You can get the data in this Eventhouse. These are all the different options available. You can start querying this data using KQL query set. You can also run notebook. You can have any visual. You can pin that visual to the real-time dashboard. This is regarding data policies is regarding retention or caching. You can change the settings here. We mentioned earlier that this data in the real-time data is not available by default in OneLake, but you can configure by coming here, and then you can check this option is on, then your data will be available in OneLake. For right now, it is by default is off. Okay, now let's go ahead and go to our workspace and create an event stream. So let's create a new event stream. So we're gonna name it event stream, and we're gonna name it bikes event stream. Okay, so now our event stream is here. First, it will ask you to add a source, which could come from different data sources, or you can build a custom endpoint, or you can make use of a sample data. Let me show you all the different options available here. Click on view all sources. Here you can see all the different sources. It could be coming from externally, from Amazon Kinesis data stream or Apache Kafka. Could be coming from internal, Azure, Cosmos DB, CDC, Change Data Capture, Azure Event Hub, IoT Hub. Could be coming from Confluent. You can also configure Fabric Workspace items. For example, if you can get live Fabric Workspace item events such as creation, deletion, and monitor that. You can also have data coming from Google Cloud Pub. And so yeah, so all these are all the different options. So in this video, we're gonna make use of a sample data. Click on this and give it a name, bikes RT. And here are the different sample data which are available. You can see here, we're gonna select bicycles. Click on add. Okay, so now you can see the data which is available in this sample. We have bike point ID, which is corresponding to the bike station number, and then you have the street, where is this station located, in which street, in which neighborhood, what is the latitude, longitude for the station, what are the number of bikes available in the station, or number of empty docks. Now after creating the source, you can add a transform event, and these are all the different operations which are available here. You can filter the data, you can manage the fields, whether you want to select all the fields or add a field or delete a field. You want to aggregate this data, join it with some other data source. You can group by, you can union, which is basically append. You can add this destination. The destination for event stream could be lake house, event house, or you can have another derived stream from a stream. You can also send the data directly to an activator, or you can also send the data to a custom endpoint. So in this case, we will send the data to our event house. Let's click on that. Let's make the connection between these two. Okay. Now we need to change this. Okay. Let's give it a destination name. So we will call it bikes raw data. And where is the workspace? We are working with bike RT analytics, bikes Eventhouse, and we will call it the destination. Under the KQL database, right now we do not have any table, so we will create a new table. Still spinning. Okay, yeah, we can go ahead and create it. We'll call it bikes data. It'll be in JSON format. Click on save, and now publish this event stream. Okay, now our event stream is published. Now let's go ahead and look at our workspace and go to our event house. Okay, click on the KQL database. Let's refresh this, and now we can see our data table here. Now the materialized view and the data streams options are not grayed out because we have tables. So because materialized views are built on top of the already existing table. So you have a KQL query set. Here you can run your KQL queries. It also, Microsoft is providing a KQL reference guide or a KQL cheat sheet if you want to convert SQL to KQL. You can click on follow link and you can go to the documentation here. So these are all the main different operators or functions which are used in KQL, and what exactly they do, what will be the syntax. It uses a pipe operator here, you can see, for the where, and take is showing your top specified number of records. Okay, now let's go back, and what we want to do is probably see the data in this. So let's go query this data, show top 100 records. Okay, so now we have the data available from our event stream. And this is a KQL query. You first specify the name of your table, KQL table, and then use this pipe operator, and take operation is specifying a specified number of records, so it will show the 100 records. And if you're just starting with KQL, You can also make use of this trick. You can use explain and then select your SQL query. For example, I want top 100 records from this table bikes raw data, and then now shift and enter it will convert the SQL query into KQL. Here. Now you can use this. I hope it will be useful. Now this is our bronze layer data. This is right now in a table. Now we want it to be stored, like maybe we want to have folder structure under it. Now we will be making use of .alter table. It's a management command for KQL database. You have to give the schemas, so we know we need to get the schema for this one. Let's get that table. Let's get the table schema. Okay, so now this is given as table schema. We will make use of is project operator. So we want to get is just a project column name, and for that we need to mention after the get schema here. Now it's not showing an error. It's the correct syntax, and now you have these. Okay, because you need to mention that when you make use of your alter table. Okay, let's write this in another query set. We can give it name also. It is bikes bronze data. So this is our schema. So will be .alter table. We're going to provide the table name, so that will be bikes raw data. You can see that here, and Control-C, because we had our bikes raw data. Now we need to provide the schema. We want to make use of this. Okay, so here our schema, the syntax is you need to provide colon separated by comma, colon, comma. Okay, now we have our schema, and now we can provide as width. Provide the folder name, so we want to put it under bronze folder. Okay, so now let's move this, and we can also comment out what this is doing. Moving bikes raw data table to bronze folder. Okay, now let's run this. Okay, now so it is created a bronze folder. Under there we can see our bikes raw data. We do not have any time field in it. Let's go back to our event stream and let's modify that, and let me show you how we can modify and add an inbuilt timestamp field in it. Okay, so now we're gonna edit this event stream, and we will be transforming the events, and we'll make use of manage fields activity under that, and this will be ingesting to data. Okay, let's delete this connection and connect this to the manage fields, and manage fields will then be connected to the bikes raw data. Okay, let's first modify this. Okay, now let's modify this manage fields. We'll call it manage fields, and then add field, and we want to select all the fields we have available, but we also want to add an inbuilt timestamp and we will call it timestamp. Okay, timestamp. Okay, to be selected. Okay, yeah, so these will be all the fields which will be available, and this data will be available. And try to refresh. Let's publish our event stream. This has been successfully published. Now if you go back to the workspace and go to your Eventhouse, go to the bikes Eventhouse, and then go to your bronze table, refresh. After we modified our event stream, I also had to do small changes to our event stream. The destination, I had to rebuild it and run this query again by adding the timestamp time. So now if you go to the branchlet folder and go to the bikes raw data, you should see timestamp along with all the other fields, bike point ID, which is bike station ID, then which street is it located, neighborhood, longitude, and all the other information, ingestion time. This is an inbuilt which is available in KQL database. We want to see is how many bikes do we need to fill, which will be equal to number of bikes minus a number of empty docks. We want to take an action based on that, whether it's a positive number, if it's a negative number, no action. We just want the bike station ID, and we don't need this string bike points underscore. So we will do those transformations. We'll make use of parse operation and extend operations. Let me go back. We'll add a new query, KQL query set, and we will call it silver queries. So here you can do it in two different ways. First is we do not have a silver table ready. If you have a table already, we're gonna name it bikes transform. Let's name it as bikes transform data, and it will coming from bikes raw data. Okay. If you have a table already created, then you can make use of into operator, and you can ingest the data. Write your query. Or if you do not have a table, for example right now we do not have, so we can make use of set or replace, and this is the syntax. So you will mention a source table, and then we want to parse the bike point ID with a wildcard, and so we are using the star, and then we do not want bike points ID, we just want to extract the bike point ID number, the int, and then store it with the same name, bike point ID, with a integer data type. Then we want another new column, so we will use extend operator for that, and which will be bikes to be filled, which will be equal to number of empty bikes minus number of bikes. And we also want to add another column called action. If the bikes to be filled is positive, keep it, otherwise we want is NA not available thing to show. So for that we are making use of if, and we are converting this field to string. So yeah, so these activity will be taken care by this. Let me show you how you can do it, set or replace. Let's run this. This is for ad hoc analysis if you do not have a table already available. So now you can see is we have data available in our bikes transformed table, and we have the new columns bikes to be filled and action available here. If it is a negative, we don't need any action. Otherwise, we want action is these many fields we want to fill. These many bikes we need to fill at that station, and this is the showing just the number. It has removed the string. Let's go back to the query. So this is for ad hoc analysis for all the incoming data. Otherwise, we'll have to run this query manually. We will make use of is function. We will put this query in a function, and for that the syntax is you use create or alter function, give the name and give the folder where I'm going to put this under a silver layer, this table, and this is a query. So now we're giving the query, this is a function name transformed bike data, And now let's run this. Okay, so now this is run successfully. Now let's go ahead and see. Yeah, under there it has created a silver layer folder, and it has created a function called transform bike data. Now we will use an update policy on bikes.data. Okay. So now we will be creating a new policy. So click on new, click on table update policy. So it will create you a query. So here we need to provide these inputs. Which table do we want? We want our silver layer. Okay, the name of our table is bikes transformed data. We want to update this table so we don't have to manually run the query again and again. We want it to be enabled. Provide true. This will be Boolean value. Yes, true. Source, what is the source table name? That is bikes. Raw data. And what is our query? So here multi-line queries are not supported. That's why we had to wrap up our KQL query in a function. So we're going to give the name of our function. So that will be transform bike data. And is it transactional? We're gonna set it as false, otherwise the data will not be ingested in the source data if it is enabled true. You can check out about that more, like if you click on this link, and you can see the details about each one. Propagate ingestion properties, we're gonna keep that also as false here. And now let's go ahead and run. So now our silver table will have bikes transform data. That will have a policy update, and that is enabled true. Whenever data is available in the source, it will transform it based on this query available in this function by transform bike data. Now let's move our bikes transform data also in a silver layer folder. So for that, first let's get the schema. We need the schema. Get table schema. Okay, and now we want, okay, these are all our silver queries, so I will store these in my previous tab. Let's go here. So first we ran an ad hoc query, step number 1 here, ad hoc query for analysis, otherwise you have to run it manually. And then we created function to transform bronze raw data, and then we enabled the policy, enabled update policy for silver table using function. Okay, and moving this table. So let's get schema on this. Okay, now we just want to see, is just like here we did. We're gonna make use of the bronze query, and we just need to show is column name and column type. So let's go ahead and do that. Okay, now we know. It says okay, copy that. All these are available, so I think we just need is to change this timestamp is datetime, and this, instead of bike point IDs, this is int, And we have 2 more columns, bikes to be filled in action. So just copy those ones. Should be good. Don't need to colon and comma. Okay, so we're gonna name it as silver. We're gonna move it, just moving this table to the silver folder. Okay. Let me check. Oh, and this will be bikes transformed data. We're altering this table. Okay, so now this silver folder has been created, and now we have our bikes transform data there. And now we're gonna do some aggregations and move this data to gold layer. For that, we will create a materialized view, which are good for aggregations, and also you will not have to create a function or an update policy that is by default enabled at the back. For writing the queries for gold layer, let's create a new tab and let's give it a new gold layer. So we're going to create a materialized view, make use of this query. The syntax will be create or alter materialized view. It will be created with folder gold, and the name of the data will be aggregated data on table bikes transformed. We want to find is a number of bikes for the latest time stamp for each bike station ID. So let's go ahead and run this query a second. Column expression named by, okay, yeah, it will be bikes transformed data here, name of the table. Okay, yeah, so now we have our materialized view available under the gold folder here, you can see, and we have the aggregated data here for the materialized view. Yeah, so now this data we can visualize. If you want to visualize, we'll write a query for this. We want is aggregated data, we want sorted by, I'm going to sort it by bike point ID, and then we want is build a column chart on top of that, so you can run this query and you can visualize this data. So for each bike station IDs, they have been sorted, and then for each one you can see the number of bikes for the last time stamp here. Yeah, you can see the number of bikes for this station number. If you hover over it, 181, it has 3 bikes available. You can pin this visual to real-time dashboard. Let me do that. So we will give it a name, bikes, number of bikes, bike point, station ID. Okay, we want to show it like that. Okay, we want to make any changes, formatting changes, we can do that here. And now let's go ahead and publish, let's pin it to the dashboard. This will be do not have a dashboard, so we're gonna create a new dashboard. We're gonna give it name London Bikes RT dashboard, and tile name will be same we have given here. We'll call it bikes by bike station. Give it a go. Okay. Okay. This will be bikes RT dashboard. Great. So this is how you can create a new real-time dashboard and pin the visual. Yeah, so now here you can see, and right now this is in viewing mode. We can click on editing and make other changes to it. We can set alerts on top of this dashboard here. If we want to add more tiles, we can do that. Go from viewing to editing mode, and now let's add a new tile, And for example, if there is any critical neighborhood, we want to see the bikes or data, and we can make use of any layer of data which is available in our Eventhouse. And for example, here we want to see is in our Chelsea neighborhood, what is the data? It is higher prioritized or something, depending on your business need. Where neighborhood is equal to Chelsea. Okay. Now let's keep this. Apply changes. Run. And we want to add a visual on top of that, but we want to show it as, let's keep it as a table. We just give it a tile name. This is Chelsea bikes. Okay, I think this looks good. Apply the changes. Okay, now here you can see all the bikes in the Chelsea neighborhood. We want to add is another visual where we want to see is maximum number of bikes which have been available in Chelsea area per street. So let's go ahead and add that as well. So we're going to do is bikes, raw data, and we're gonna add a filter where neighborhood. We're gonna write we are writing a KQL query. Neighborhood is equal to Chelsea. Now we want to summarize this. Okay, let's summarize a pipe operator. Summarize. We're going to summarize is max or number of bikes by street. So right by street. Okay, now let's run this query. Let's see the results. Okay, yeah, so here you can see for each street, these have been the number of bikes which have been available. Maybe these are important to us. We want to make sure we have a threshold. It never goes above below that. Maybe we want to set an alert on this. Okay, we can add. Okay, let's give it a name. We can edit it. Chelsea street bikes. Maximum bikes by street. Okay. Apply the changes. And maybe we want to show it as a column chart or anything. You can change that as well. Let's edit this, and instead of visual, we want to is a bar chart. So this is how it will show, and you can apply any formatting you want here. Yeah, so for me right now it looks good. Let's go ahead and apply changes. Yeah, so it's showing is a maximum number of bikes available. We had the longitude, latitude data available. We want to show that in form of a map, and let's add that. We'll add a new tile. Okay, and we just want to see is order by raw data. We want to see all the bikes which were available 5 minutes ago. So we'll put as timestamp. Go 5 minutes. You can put 1 hour. Yeah, so we want 5 minutes ago. Yeah, so just add where here. Should be good. Now let's go ahead and see this. Your operator. Yeah, it's a very case sensitive language, so make sure that the names are in correct format. Because we have latitude and longitude available in our bronze data, which is not available in our aggregated data, so that's why we are running this query on bronze data. And now let's go ahead and edit this visual. We can add a map instead of a table. We have an option available. Yeah, map here. And now we're going to define the location by latitude and longitude, and our latitude column will be latitude, just dynamic data type, and then we have longitude. Okay, so yeah, now you can make any changes here, or to the query. If you want to show it just for particular neighborhood, you can add that filter here. Right now we can just show it, or if you want the number of bike size to be reflected by the size of the circles, you can do that as well here. Yeah, you can play around with all these different options. So this is all showing you, and you can zoom in or out, or any particular area you want to show. For example, maybe we want to see Chelsea area. Here is all your Chelsea area, or how many number of bikes are available. If you click on it, it's showing you label column. No, we want to see is the number of bikes. Okay, let's click on it again. Yeah, so it's showing you is the number of bikes available 5 minutes ago in that particular location. Now click on apply changes, and you should see the map here. And one more time, let's edit it, give it a tile, bikes, 5 minute, go status, apply changes. Now we can refresh this. Let me see, there should be an option, data source manage. Yeah, if you go to the manage, you can select an auto refresh and how you want this real-time dashboard to refresh. Maybe we want it to be refreshed continuously or every 1 minute, and then every 1 minute just refresh this, apply. So you have every 1 minute this data is refreshing. And now we can go ahead, go to home, and maybe we want alerts whenever bikes falls below certain level. So let's go ahead and do that. Let's see, set an alert. We want to set an alert. Maximum bikes should never fall below a certain value. We want it to never less than, maybe we can give it an arbitrary number here. It should never fall below 10 or 5. Or you can either send an email or message in Teams or run a fabric item on that. Let's go ahead and do it. Send me an email, and it will create a new item. We'll give the bikes RT dashboard alert. Okay, let's create. Right now it might fail because I do not, this is a free trial which I've set up based on my personal account, so do not have an Outlook. But let's go ahead and see if it creates an error. Okay, right now, okay, it did. Created, and now yeah, let's go ahead and save this real-time dashboard. Navigate to the Evenstream, and let me show you how you can create a derived stream. If you have, for example, worldwide data, but you have other teams in different countries or different departments, and they want a derived stream filtered just for their particular region or department, so you can go ahead and do that. Click on edit, and let's go and pull this down. We will transform this data. We will add a filter, and this stream, so the stream is coming. Okay, so we want to set up select a field. In this particular sample, we only have these fields available, so I'm applying a filter on neighborhood. It could be a department or a country, region, or depending on the field. So it should contain Chelsea. Okay, now save, and now it needs a destination, so we'll create a destination. That's why it's showing an error right now. So we will go into it, so it'll go to a derived stream which can be used by that particular department. Okay, let's give it a name, Chelsea bikes RT and I'll save it. Okay, so now this looks good. We can also do is we can send the data directly on the event stream, create an alert on it. So here we can add a destination, which could be an activator, and we'll give the name of the activator destination, just bikes activator destination. Okay, we'll give it a name, which workspace we want in bikes RT analytics. We can create a new one, or we can send it to the same activator. Let's create a new one for this one. Bikes Evenstream raw alert. Okay, it'll create a new one, and now let's go ahead and save this. Configure this to this activator. Yeah, that is how you can get the data, and you can add fields to it. You can filter this data, get a derived stream based on it, which can be used by some other team or region, and then you can also do is send this data to an activator to trigger an email or an action based on it. Now let's go ahead and publish this, and let me show you how you can configure this. Let's go to the activator. Yeah, this is the activator on there, and now we can modify it. We can add a rule here. There is right now no rule. We just created an activator, so here we can add a condition to it. Numeric state is equal to or is less than whenever the bike. Select a column if the number of bikes ever falls less than 2. Then we want to take an action based on that. So do you want an email, or do you want a Teams message, or do you want Fabric item to run after this? So right now, for example, we can set it up to email. You can save activator. Okay. If you ever want this activator to stop, you can come and click here. And yeah, you can click on edit here and then see, or just view option. Now let's go back to our workspace. Now let's add our task flow to it. We first suggested the data, so we'll get data, and that data we got through is Evenstream. So we will create a task flow. We're gonna attach item to it. So we ingested using the bikes Evenstream, and then that data was then we'll add a new one. So after that we stored this data, and we stored it in our Eventhouse. Select, and then we did these are connected, and then we visualize this data. So we're gonna click on visualize data. We visualized it using our dashboard. Dashboard. Click on that, and we can also track this data. So we are tracking this data using alerts. This is our workflow that looks like. Now let's go ahead to the dashboard. This is refreshing. Here you can see less than a minute ago we have set up an automatic refresh rate here. Every minute we ingested the sample data from Microsoft Fabric using Eventstream, and then we ingested the data into Eventhouse KQL Database, and it moved through different layers, raw data in bronze layer, then we added columns and made changes in silver layer, and then we aggregated data in gold layer by making use of materialized view, and then we built a visual on top of that and put it in our real-time dashboard. We added another tiles from different layers, so from bronze layer, and we also saw how we created a derived stream. Yeah, I hope you find this video useful. If you do, please like and subscribe it. It really helps me keep going. Until then, see you next time.